Hello and welcome to the walkthrough of the solutions of 2017's C4 A-Level Maths paper. Question 1, as usual, is a nice partial fractions opener to get us warmed up. Nothing too unusual about the first part. Express this in terms of partial fractions. So those of you who I have taught will know that for some reason I can't handle it when the squared term is on the left, so the first thing I do is put the squared term on the right. That's just my routine and not essential. Then of course we split this up into three fractions. A over the first denominator, B over the singular term of the squared, and C over the squared term. And then do a bit of cross multiplication magic. Bring the squared term up in front of the A, bring one each of these up in front of the B, and bring the left-hand term up in front of the C, and that becomes our new numerator, which we can equate to the original numerator of 8x squared plus 7x minus 25. And that's where this line has come from. That's just equating those numerators. Now the idea is now to eliminate two of these by picking the correct values of x. So you can see if you select x as being 1, initially, 1 minus 1 is 0, that eliminates the A, 1 minus 1 is 0 there, that eliminates the B, and allows us to get a value for C. So if I put x equals 1 into this expression, I get negative 10. If I put x equals 1 into this expression, I just get 5C, which allows us to determine that C equals negative 2. The next one, I can eliminate these brackets here by putting x equal to negative 4. So if I put x equals negative 4 into this expression, be careful with it, especially with the squared term, I get 75. That disappears. Negative 4 minus 1 is negative 5 squared is 25. So A comes out as 3. 9 times out of 10 they are whole numbers. But I have seen some rather horrific looking fractions one year, but it's always worth double checking if it doesn't come out as a whole number. And then to get the third value of B, you can put x equal to any value really, as you already know A and C, but 0 is probably the easiest as it eliminates quite a lot of the expression. So putting x equal to 0 in here just leaves you with negative 25. 1A, and A is 3. 4C, and C is minus 2, which gives me the minus 8, and then this here leaves me with minus 4B. Rearrange that and solve, and you get B equals 5. The last step to get the final mark then is to rewrite this original expression out now, but with our value of A being 3, our value of B being 5, and our value of C being minus 2. Right, nothing too tricky there. I'm sure you've learnt that routine. The second part, and it's in bold, so they must mean it. Use your result to part A to express this in terms of partial fractions. So if you do the whole process again, you will get 0 marks. It says to use your initial result. Right, that was the original expression we had. That's the one they want us to determine now using this. So obviously the denominators are the same. What's changed on the numerator? Let me just slide this up a little. And you can see we have an extra x squared term. We have 2 less terms of singular x, and we have a difference of 1 here for the numerical term. So effectively, this is my original term plus x squared minus 2x plus 1. Of course, x squared minus 2x plus 1 factorizes to give x minus 1 all squared. You need some pretty good nerd skills to spot that, but also you knew it was going to be that because it's on the denominator. So effectively, they cancel each other out to leave just 1 over x plus 4. Rewriting this out now as my separated partial fractions, and then add the 1 over x plus 4, well, you can see these two match up here. I have 3 over x plus 4 plus 1 over x plus 4, which obviously equals 4 over x plus 4. And then write down the extra 2 terms. This has come up twice, this type of question, in the last few years, okay? So it's about thinking, how do I get from this numerator to this numerator? and generally then that will factorize somehow to eliminate one of the factors on the bottom. Practice makes perfect. That's a pretty good 7 marks to start.